Yes, welcome back. Welcome back to EDUHUNT IIT and NEET Foundation classes. This is Sukumar, your chemistry mentor. See, in this particular video, we are going to discuss what is hydrogen bond. See, if you take a covalent molecule, as an example, if I take a covalent molecule which is having a covalent bond between two different atoms. Let's take for the sake of example a bond between hydrogen and chlorine. Let me take that as an example. There is a covalent bond between them. Yes. Now you know very well. Compared to hydrogen, chlorine is more electronegative. Compared to hydrogen, chlorine is more electronegative. And what is this line, students? This line is nothing but the bond pair, the shared pair of electrons. You know very well. I explained so many times that hydrogen has contributed one electron and chlorine has contributed one electron. That is the electron pair. Now this is the electron pair. Now this electron pair is equally or supposed to be equally shared by the two atoms, right? But you know very well, chlorine is the electronegativity of chlorine is greater than electronegativity of hydrogen. You know that. Now, sir, once again tell me, sir, what is electronegativity? Yes, electronegativity is the tendency to attract the shared pair towards itself. That means this is the shared pair. To attract this shared pair towards itself, hydrogen has its own tendency or chlorine has its own tendency. So, the tendency of this atom or that atom to attract this pair towards itself can be called as electronegativity, and that electronegativity is more for chlorine. So, then because of that, what happens? Because of that, you can say this pair, particularly this pair, is more towards chlorine and less towards hydrogen. Comparatively more towards chlorine. You know that. Previously also I explained. And because of that, what happens? This pair is more towards chlorine, but not completely towards chlorine. If this pair is completely towards chlorine, or if this pair completely shifts towards chlorine, then chlorine will get a complete negative charge, full negative. But here what happening? This pair not shifting towards chlorine completely, but partially shifting. So if this pair fully shifts, chlorine will get full charge. Partially shifts means chlorine will get partial charge. So chlorine is having chlorine is having that some amount of partial charge developed here. Partial negative, partial positive. So I explained this in polar bond or polar covalent. So this way, this molecule has got some polarity. That means chlorine has got partial negative charge, negative pole on this side and positive pole on that side. So this leads to dipole moment. We completed the topic, dipole moment. Now this is polar molecule. Fine. Now, after understanding or remembering this concept completely, now take this kind of two molecules side by side. Take this kind of two molecules side by side. That means HCl, HCl. Now if you take HCl, hydrochloric acid or HCl, okay. When you take HCl, obviously this molecule is having that partial negative, partial positive charge, and that molecule also having that partial negative and partial positive charge, right? Side by side I have taken two molecules, but you can imagine in matter the number of these molecules side by side is huge now. So I am taking two molecules. Then obviously you can guess something here. What? There is, obviously there will be an attraction between this partially positive charged hydrogen and partially negative charged chlorine. Obviously, right? Yes. I am showing that attraction like this. Okay. Fine. Yes. The point is, this attraction is called. This attraction can be called or called. This attraction is called dipole attraction. Dipole attraction. The name is very much justified, I think, right? How? This is a dipole having polarity, negative pole, positive pole, dipole. This is another dipole, and the attraction between dipole and dipole is otherwise the dipole attraction. Fine, fair enough. Now, take a similar kind of example. Now I am taking a similar kind of example, but with different electronegative atom, which is somewhat more electronegative than chlorine, or you can say more electronegative than any element in the periodic table. That means in the place of chlorine I am taking hydrogen, but in the place of chlorine I am taking the most electronegative atom. Which one? Which one is the most electronegative atom in the periodic table? Yes, fluorine. So I am taking HF. Now try to understand the situation. Same kind of hydrogen and fluorine is sharing that shared electron pair. There is a shared electron pair. That means this pair more towards fluorine, partial minus, partial plus, right? Now try to guess something here. The amount of charge, of course it is partial charge, but there is some magnitude of charge, na? Yes. The magnitude of charge appeared here depends upon the electronegativity. If more is the electronegativity of this atom, more will be the charge appeared here, na? Because because of that electronegativity only, this chlorine is pulling this electron pair towards itself. Because of that only, chlorine is getting that amount of partial negative charge. So more is the electronegativity on this atom, more will be the charge. And you know very well, compared to chlorine, fluorine is more electronegative. So simply you can guess that compared to the partial charge appeared here, the magnitude of charge appeared here will be more. No doubt about it. Fine. Now, take another same kind of molecule, one more molecule side by side. I am taking another molecule of same type beside it. Now, same kind of concept also appearing here. As you studied here, there is a dipole, there is an attraction between the partial positive charged hydrogen. There is an attraction between this partial positive charged hydrogen and partially negative charged chlorine, and that attraction we named as a dipole attraction. Now, the same kind of attraction you can expect here. Yes, there can be a attraction between this partially negative charged fluorine and partially positive charged hydrogen attraction. Okay, but you can simply guess the attractive power or the attraction here will be more than here, because compared to chlorine, fluorine is more electronegative. More electronegativity leads to more magnitude of charge. More magnitude of charge leads to more attraction. So that's why here there is a dipole, but the attractive power here is not called as a dipole attraction. This attraction is otherwise called hydrogen bond. This attraction is called hydrogen bond. That means, sir, the same kind of attraction here, you called it as dipole attraction. But there, the same kind of attraction you are calling with a different name. Yes. The point is, for the attraction to be called as hydrogen bond, the attractive power must be sufficient value. The attractive power must be sufficient value, and the electronegativity of the atom must be a sufficient value. Okay, so in general, when hydrogen is present on fluorine, when hydrogen is present on oxygen, when hydrogen is present on nitrogen. So three atoms I mentioned: fluorine, oxygen, and nitrogen. So when hydrogen atom is present on any of these three atoms, then only the attraction of this kind is called hydrogen bond. So let me define first. Let me give few more examples. Then I'll define. See, let's take water molecule, or take oxygen atom and hydrogen. I hope you know oxygen is divalent. There can be another bond. Fine, leave that bond. Whatever atom may be connected there. I am taking hydrogen. So compare it to hydrogen. Oxygen is more electronegative. You can partial minus, partial plus. Then obviously there is another hydrogen or another molecule you can take here, like this water molecule. Obviously this also partial minus, partial plus. So there can be a weak attraction between this partially positive charged hydrogen and partially negative charged oxygen, right? And this hydrogen can also form that kind of attraction. This hydrogen can also form, and this oxygen can form two attractions. I'll explain later why two attractions. The point is, you can expect a hydrogen bond when hydrogen is present on fluorine or oxygen and nitrogen also. Let me give that example also. When nitrogen is having hydrogen, and I hope you know nitrogen is trivalent. Generally there can be three bonds. Yes, partially positive charge. Now the partial positive charge will be on hydrogen, and partial negative charge. I'm considering only this bond. I'm talking about one bond. Then obviously you can have another example. Hydrogen. Yes, partial positive charged hydrogen, partial negative charge. I'm considering only this bond. Fine. The attraction between these two atoms. Sorry. Yes. Now, the attraction between these two atoms can be called as hydrogen bond. This dotted line is hydrogen bond. Okay. So the point is, now try to define what is hydrogen bond. Hydrogen bond is a weak attraction. What kind of attraction? It is electrostatic force of attraction. The attraction between oppositely charged particles. In general, the attraction between oppositely charged particles is called electrostatic force of attraction. Yes, hydrogen bond is an attraction, electrostatic force of attraction. Between what? Between partially positive charged hydrogen. See, in every case, this is must. Hydrogen with partial positive charge. Partially positive charged hydrogen and partially negative charged more electronegative atom like fluorine, oxygen, nitrogen. See, here hydrogen bond is present between, look at here. Hydrogen bond is present between partially positive charged hydrogen and more electronegative oxygen. Partially positive charged hydrogen and more electronegative oxygen. Partially positive charged hydrogen and more electronegative nitrogen. Partially positive charged hydrogen and more electronegative fluorine. So what is must and should here? Here, hydrogen must be present on nitrogen or oxygen or fluorine. The electronegativity of these three atoms is only sufficient to give or to produce this hydrogen bond effect. Okay? Yes. Let me define in the next page. Definition. I am giving definition here. The First of all, it is weak attraction. Compare it to normal hydrogen, normal bond, normal covalent bond. Compare it to normal covalent bond, it is weak. It is weak. Fine. The weak electrostatic force of attraction. Electrostatic force of attraction. The weak electrostatic force of attraction between partially positive charged hydrogen and partially negative charged more electronegative atom. See, I am writing electronegative as EN. Short form I am writing. I hope you consider this. More electronegative atom like oxygen, nitrogen or fluorine. Oxygen, nitrogen or fluorine of same or different molecules. Or any chemical species. See, let me read this first. The weak electrostatic force. Try to understand the hydrogen bond. What we understood previously with the example, try to understand the same by the definition. The weak electrostatic force of attraction. Yes, it is weak force, I told you. Compare it to covalent bond attraction. See, any bond means attraction. Compare it to covalent bond. This is weak. And it is the electrostatic force of attraction, the attraction between oppositely charged particles. Yes. The weak electrostatic force of attraction between what is important here? Partially positive charged hydrogen. This must be present. Hydrogen must be present, and on that hydrogen there must be partial positive charge. But hydrogen with partially positive charge, when it will appear? Whenever the hydrogen is present on more electronegative atom, then only the hydrogen with partial positive charge is possible, na? Yes. So partial positive charged hydrogen and partially negative charged more electronegative atoms. Partially negative charged more electronegative atoms. So this is very important to understand. Hydrogen must be present on partially negative charged more electronegative atoms. There can be more. See, the electronegativity of, generally, you know very well, in periodic table and chemical bonding chapters we discussed it. The electronegativity of hydrogen is taken as a reference. Compare it to the electronegativity of hydrogen, we decided the electronegativity of other atoms. So, compare it to hydrogen, there are so many atoms which are more electronegative. Compared to hydrogen, there are so many atoms which are more electronegative, but all atoms here doesn't lead to the hydrogen bond formation. Only when hydrogen is present on more electronegative atoms like nitrogen or oxygen or fluorine, these three. Okay? Yes. Partially negative charged more electronegative atoms like oxygen or nitrogen or fluorine of the same or different molecules is called hydrogen bond. Hydrogen bond. See? So, where you can expect this hydrogen bond, I can give examples here. Few examples like in H2O. In H2O. In H2O, hydrogen is present on more electronegative oxygen. In ammonia, you can expect hydrogen bond because in ammonia molecule, hydrogen is present on more electronegative nitrogen. And hydrogen fluoride HF. HF. In HF, the hydrogen is present on most electronegative fluorine. So, one thing is there must be hydrogen, but that hydrogen must be present on 3 electronegative atoms. 3 electronegative atoms, any of the 3, that is oxygen or nitrogen or fluorine. Oxygen, nitrogen or fluorine. So, when hydrogen is present on more electronegative atom, but other than these 3, then you can expect that dipole-dipole attraction, right? In the beginning I explained. Here hydrogen is present on chlorine. Of course, chlorine is more electronegative. Here also you get that partial negative charge, partial positive charge. Here also there is an attraction, but that attraction is not hydrogen bond, that is a dipole-dipole attraction. Yes. Now, you may get little confusion at this part. This entire part is okay. The weak electrostatic force of attraction between partially positive charged hydrogen and partially negative charged more electronegative atoms like oxygen or nitrogen or fluorine of same or different molecules. Same or different molecules. Okay. This part of this definition you will understand once I explain what are the types of hydrogen bond.